Hi everyone, my name is Devon Terrell, and today we're going to be talking about some of Python's foundational collection types. So all of these can be found if you import collections.abc, and the motivation for this talk came from an interview that I ran last week where a candidate was particularly confused about iterators. So we're going to start off by looking at some code here. So this is a little Python script that reads in a text file, and then it counts all of the lengths of the lines in the file to calculate the average line length. And then it goes through those lines again to figure out which lines are larger than the average line length. So you can imagine if you had like a text file full of log statements or something, most of those logging statements are probably a pretty normal average size. But every once in a while, you'll get one that contains a massive stack trace or a logging dump or something like that. This might help you sort through those and try to find those stack traces. The interesting thing here is that without running this, without seeing what's in that log.txt file, we can actually tell you what this is going to output. It's actually just going to output an empty array here. And the reason why, to figure out why, we're going to have to go through and introduce a couple of those types. So first, we're going to talk about iterables and iterators. So in Python, iterables are anything that has an __iter method. And you can pass those objects to the built-in iter function, and that will return an iterator. So what's an iterator? Iterators are things that have an __next method, and you can pass them to the built-in next function. So when you pass an iterator to the next function, it's going to give you the first item in a collection. Iterators are stateful, so if you call next again, passing that same iterator in, you'll get the second item, and then the third item, and so on and so forth, until eventually you run out of items. And then Python will raise a stop iteration exception, and that sort of indicates that the iterator has been fully iterated over and you fully consumed it. The important thing to note is that iterators are also iterables. And why does this matter? Together, iterators and iterables are how for loops work in Python. So when you have a for loop like this, so we have for item and items, the first thing that the Python does is that it's going to call iter on items to get an iterator. Then it's going to repeatedly call next on that iterator to get each item. With each item, it'll execute the loop body until eventually it runs out and it'll raise a stop iteration. The for loop catches that stop iteration. It notices that you've fully consumed that iterator. And then if you keep calling next on that iterator over and over again, it's just going to keep raising stop iteration. So this is actually where the bug in our program comes from. So if we walk through this program again, on the first line here, we open this file, and files are iterators. They iterate over the lines in that file. In this first for loop, we consume that iterator. We loop over the lines in that file in order to calculate the average line length. Then when we get to the second for loop, it's empty, right? We've already consumed that iterator. When the for loop launches and tries to call next on that iterator, it sees that it's already been consumed. It raises stop iteration. And so we don't ever actually process this body of the for loop. So why are iterators and iterables confusing? Both support the for loop syntax, right? So for e in iter thing, you can pass in either an iterator or an iterable, but the behavior is different. For iterators, the iterator will be consumed fully exactly one time, and then that's it. If you use the same iterator on another for loop, it will appear as if the sequence is empty. Iterables, on the other hand, that are not iterators will produce a new iterator every single for loop that they get used. So even though iterators can be used as a drop-in for anywhere we expect an iterable, the behavior is different. This means that when you're given either an iterator or an iterable, it's not always clear exactly which one you're working with. Since you can use both in a for loop, it's not always obvious if you're using an iterator that can be used exactly one time or an iterable that you can iterate over and over again. This also leads to some kind of silent and unexpected behavior. That first program that we showed didn't cause an exception, didn't crash the program. Just the second time that you went to iterate over that sequence, it was empty. And then the third issue with working with iterators and iterables is that the location where you observe the bug might be far away from where it occurs. So if we go back to this program, you can imagine, like, even though this is short, it fits on one slide, you can imagine layers of code, lots of lines in between these two for loops. And so when you get to where you're actually observing this empty sequence, it might be far away from where the first iteration occurred. So sometimes when you run into these types of bugs, it's hard to sort of trace back to where that first iteration occurred and where you consumed the iterator. So if we how do we fix our program here, right? We see this names.seek line. This is kind of a little special quirk of the file iterator. You can actually reset that iterator. By calling seek 0, you're telling it to go back to byte position 0 in the file. And if you do that before the second for loop, then you can iterate from the beginning again. The important thing to note here is that this is not a standard call in Python. This isn't something that is captured as part of the collections base types. This is just a quirk that file iterators have. So you can imagine if we wanted to extract this out and turn it into a function, we have to decide what kind of iterable we want to consume. So if we extract our function here, we're trying to provide a type hint for this lines parameter. What do we pick? If we choose iterator, then we are saying to the caller, we're only going to iterate over this one time, which is obviously not true for our particular function. We need to go through one time to calculate the average line length, and then we need to go through again to collect the lines that are larger than that length. If we use iterable, then nothing stops the caller from also passing in an iterator, because all iterators are iterable. So we're kind of left in a bad spot. What do we do? Well, there are a couple of other iterables. So these, remember, iterators are iterables, but not the other way around. So one of our other collection types here is collections. This is particularly confusing. You can do from collections.abc import collections, and it's two different things, not collections the module, it's collections the subclass. It's kind of confusing. But collections are iterables with two additional methods on them. They have a length, they know how to calculate the size of that collection, and they also have a contains method that is supported by the built-in in syntax. You can say e in collection to test membership, and it will return either true or false. Sequences are also collections, but they also support this getItem method, which means you can index them with brackets. So you can see here like sequence bracket 0 to get the first element, sequence bracket 1 to get the one after that, right? So what are these actually, like where do we see these come up in practice? Collections are things like dict.items, dict.keys, dict.values. Those are all collections. Sets are also collections. And then the built-in methods, bars, locals, and globals all also return collections. Sequences are a lot more familiar. We see them more often. Those are things like strings, lists, tuples, and ranges. There are other collections in the collections library. I'm not going over all of them here. Notably, dicts themselves are missing from here. Those are mappings. We won't talk about those right now because we're going to go back to our problem of iterables. So why do we care about these things? Well, these collection types aren't iterators, but they are iterables. So if we go back to our function and we're trying to tell our callers, right, that we are going to iterate over something multiple times, if we pass one of these collection types, either a collection or a sequence, then that's sort of a clue to them that we need to iterate multiple times. So what are the takeaways here? First, be conservative with iterators and iterables. If you're writing code that's consuming one of these types, you have to assume that your function can only iterate over it one time. Even though somebody's passing an iterable, it may not be obvious that it's an iterable and not an iterator. So you have to be sort of conservative and assume that you can only go over it one time. If you're producing iterators and passing them around to functions, you need to be careful about sharing them. So if you pass the same iterator to multiple functions, if they're both assuming that they can iterate over at one time, but the first function has fully consumed that iterator, then it's going to appear empty for the second function. There are a couple of cases where it does make sense to have two functions that sort of mutually iterate over an iterator, but those functions need to be aware of each other and sort of agree on how they're going to iterate like with one another. The second is if you're writing code that's, again, consuming iterables, maybe prefer one of these subclasses like a collection or a sequence. Those are always things that you can iterate over multiple times. I say always with a couple of caveats there. It's not always true, but by and large, you can sort of safely assume that if you're given a sequence or a collection, then you can iterate over it multiple times. And then the last thing is that if you have to take a raw iterable as an input to your function, consider actually checking to make sure that it's not an iterator. If you need to iterate over something multiple times, explicitly make sure that it's an iterable that is not an iterator, and that should be safe to iterate over multiple times. So that's it for my lightning talk. I have a couple of other interesting collections that I'd like to talk about next time, but we only have 15 minutes. So if you want to follow up and ask any questions, feel free. You can find me online anywhere at Axiom Absolute. So yeah, any questions?